Potassium sorbate, and they give us its formula right over here, has a molar mass of 150 grams per mole. They put this decimal here to show us that these are actually 3 significant figures, even the 0 is a significant digit here, is commonly added to diet soft drinks as a preservative. A stock solution of potassium sorbate, dissolved, it's an aqueous solution here, of known concentration must be prepared. A student titrates 45 milliliters of the stock solution with 1.25 molar hydrochloric acid using both an indicator and a pH meter. The value of Ka for sorbic acid is 1.7 times 10 to the negative 5th. All right, so let's tackle this piece by piece. Write the net ionic equation for the reaction between potassium sorbate and hydrochloric acid. All right, so first I'll just write the ionic equation, and then I'll write the net ionic equation, and hopefully you'll see the difference. So ionic equation. And the way we think about ionic equations is we think about, well, if these are dissolved in water, it's an aqueous solution, these are going to disassociate into ions. And so we would write that out on both the reactant and the product side. So the potassium sorbate, we can write that as it's going to be a potassium ion dissolved in an aqueous solution plus the C6H7O2. This is also going to be an ion dissolved in the aqueous solution, plus the hydrochloric acid will dissolve, so you have the hydrogen proton dissolved in the aqueous solution, plus the chloride ion, or anion, I guess we could say it. So that's going to be in our aqueous solution. And then they react. What happens? Well, you're going to have the C6H7O2 react with the hydrogen proton to get to sorbic acid. So you're going to have sorbic acid, HC6H, this is a 6 here, H7O2. That's the sorbic acid. It's going to be in an aqueous solution. So I took care so far of that and that. And then you're going to have your potassium ions, and your chloride ions. It's going to be just like that. So this right over here is the ionic equation, not the net ionic equation. I have the ions on the reactant side, and then on the product side right over here. And I included everything. Now when you do the net ionic reaction, you can imagine what's going to happen here. I have potassium ions on the left, I have potassium ions on the right. I could net them out on both sides. So let's net them out on both sides. I have chloride ions on the left, I have chloride ions on the right. I can net them out on both sides, and then I can write the net ionic equation. So the net ionic equation, net ionic equation is going to be, well, I have my C6H7O2 ion dissolved in an aqueous solution. You combine that with the hydrogen proton dissolved in the aqueous solution, and it's going to give us sorbic acid, HC6H7O2 in our aqueous solution. So there you have it. That is the net ionic equation.